In case of electronic system design and manufacturing, especially with respect to power supply design and power supply related design engineering, power integrity is a very essential topic to consider while routing the path for the power supplies. Let's talk about the introduction of power integrity in ESDM industry in this video. Hi everyone, I am Vaibhav Sugandhi, co-creator at Linked Frequency. I have worked as a hardware design engineer for last 8 years in ESDM industry. With that experience, I am bringing you this video with respect to the basic introduction about power integrity in ESDM industry. So let's get started. Now let's talk about what is power integrity. It is an ability of a power supply or a power path that you route on the PCB to all the peripherals to supply the stable and constant, non-fluctuating and without having noise kind of a power to all the peripherals in the entire circuit. If any of the peripheral is having a problem with receiving the power supply with a minute fluctuation or minute noise, then it will negatively impact the entire circuit. This ability of the power supply and the track that we draw to supply the power to all the peripherals is called power integrity. Now let's talk about the importance of power integrity. Most of the time people think that it is just a conducting material or a copper that connects from one point to another point. What is the big deal? And when we check the continuity, it always shows the continuity. But it is not just about the continuity. It matters a lot what is the thickness of the track and what is the depth of the track and how you well manage the track to travel throughout the entire PCB. Because it is all about creative work in PCB designing, not just drawing the connections or maybe drawing the copper path. Let us consider an example to understand the power integrity or the poor power integrity impact on the circuit. Let us assume we have two peripherals or analog sensors which are connected to the microcontroller, and we have a power supply which supplies 5 volt DC as per the requirement of these data sheet of those sensors. Now, because of poor power integrity, the 5 volt power supply is not able to reach to the peripheral or the sensors exactly as a 5 volt. Just below that, which is 4.75 volt. What do you think the output of these sensors are going to be as similar or as same as the datasheet recommendation? Of course not, because of poor power source. That's the reason why power integrity is very important. If you supply a low voltage or voltage drop with respect to VCC, then obviously output of that particular sensor is going to impact negatively with respect to the power supply. That's why power integrity is an essential skill and essential topic to consider while routing inside PCBs. Now let's talk about the 3 common problems observed with a poor power integrity. What do you mean by poor power integrity? Inability of the power supply or fluctuating and having a noise in the power supply at the peripheral level. First one is power noise. Second one is voltage drop, and the third one is ground bounce. The power noise is nothing but having a noise and fluctuation in the source of the power supply itself. For example, you have a linear voltage regulator or maybe switching voltage regulator. Because of whatsoever reason, if your power supply itself is supplying a fluctuating DC voltage which is having a ripples which is more than expected or accepted level for the peripherals, then it is called a power noise. This has to be solved when you are designing a high-end PCBs, especially with respect to the power supplies or maybe the SMPS design. Second one is voltage drop. Let us assume because of whatsoever reason, the output voltage or the VCC at the peripheral is not 5 volt even though you have supplied the 5 volt on the other end. Because of path impedance or maybe the track impedance, the voltage will drop at the peripheral level. This has to be solved with respect to the power integrity, and this problem is called voltage drop at the peripheral. That's why this will cause a lot of problem. That's why it has to be solved as a power integrity part of entire methodology. Third one is ground bounce. Say for example, you have connected the power supply path properly, but you have to take care of the return path as well, because return path is very essential for any entire circuit to work properly. In case of return path is not properly managed or not properly connected to the power supply, on that time a noise will be introduced in that particular path. For example, instead of having the ground voltage as a 0, it will fluctuate between 0.25 and 0 or 0.5 and 0. That fluctuation will cause a lot of problem with respect to analog circuitry or maybe the digital circuitries which are working at very low voltages like 1.8 volt or 3.3 volt. That is called ground bounce. This has to be solved with respect to the power integrity methodologies. And this is one of the important reason why most of the people use a proper written path in their PCB designing. Comment down below if you have faced any such issues with respect to your PCB designing, and I'm very happy to answer your question if anything. I hope you have learned something new in this particular video. Share it with someone who may need it and help us to grow in the engineering community. See you again in the next video. Until then, tune yourself to make a difference.